Throughout history, Earth has demonstrated immense destructive power, from raging storms to powerful earthquakes. Yet these forces do not act at random. Instead, they follow intricate patterns that scientists have spent decades deciphering. By studying these patterns, experts can often predict when and where such events might occur, though stopping them remains beyond our reach. Beneath this predictability lies a sobering reality. Certain catastrophic triggers have the potential to dramatically alter the course of civilizations. The delicate balance between foresight and helplessness defines humanity's ongoing relationship with the planet's most formidable forces. Throughout history, natural disasters have played a profound role in shaping the course of human development. Often, the forces responsible for these events operate quietly and invisibly, deep beneath the Earth's surface or high in the atmosphere. Over time, energy and pressure accumulate, sometimes for years or even centuries, before being released in dramatic and sometimes catastrophic ways. Earthquakes, volcanic eruptions, and hurricanes are just a few examples of how these hidden processes can suddenly transform landscapes and societies. The aftermath of such disasters has influenced migration patterns, the rise and fall of civilizations, and the ways communities adapt to their environments. By understanding these silent forces, we gain insight into both the vulnerability and resilience of human societies. Natural disasters often unfold with a force and complexity that surpass human comprehension. Deep beneath the Earth's surface, tectonic plates shift silently until their sudden movement unleashes devastating earthquakes. In the atmosphere, invisible currents and temperature changes can give rise to hurricanes of immense power, their paths and intensities difficult to predict. Volcanic eruptions, driven by pressures building over centuries, can blanket entire regions in ash within moments. Tsunamis, triggered by underwater disturbances, travel across oceans at incredible speeds, arriving with little warning. These phenomena reveal the hidden mechanisms at work in our planet, reminding us of the vast and unpredictable forces that shape our world. Beneath our feet, the Earth's crust is in constant motion, driven by immense forces deep within the planet. This movement occurs along vast plates that slowly shift and interact over time. Hidden beneath the surface, fractures known as faults mark the boundaries where these plates meet. While these faults can remain locked for years, stress gradually builds up along them. When the pressure becomes too great, the fault can suddenly rupture, releasing energy in the form of an earthquake. In a matter of seconds, land can shift dramatically, sometimes altering coastlines and reshaping the landscape. These powerful events serve as a reminder of the dynamic nature of our planet. Beneath the Earth's surface, vast volcanic chambers can lie in silence for centuries, accumulating molten rock and volatile gases. These chambers often show little outward sign of activity, making them difficult to detect or predict. Over time, pressure builds within, as magma and gases continue to gather. When the chamber finally ruptures, the eruption can be sudden and catastrophic, unleashing torrents of lava, ash, and gases. Such explosive events have the power to devastate entire regions, disrupting ecosystems and human settlements alike. In some cases, the effects can even reach a global scale, altering climate patterns and impacting life far beyond the immediate vicinity of the volcano. Tornadoes originate from powerful rotating storm cells known as supercells. Within these storms, warm, moist air rises and interacts with cooler, drier air, creating instability and strong updrafts. As wind speeds and directions shift with altitude, a horizontal spinning effect develops in the lower atmosphere. This rotation can be tilted upright by the storm's updraft, forming a rapidly spinning column of air. When this column tightens and stretches toward the ground, a tornado is born. These intense funnels can generate wind speeds exceeding 200 miles per hour, capable of tearing apart buildings, uprooting trees, and hurling debris with deadly force. The sheer power of a tornado makes it one of nature's most destructive phenomena. Tsunamis are powerful natural phenomena that begin with underwater disturbances, such as earthquakes, volcanic eruptions, or landslides. When these events suddenly displace large volumes of water, they generate waves that radiate outward across the ocean. Despite their immense energy, tsunamis can travel at speeds exceeding 500 miles per hour, often passing unnoticed in deep water. As they approach shallower coastal areas, the waves slow down and grow dramatically in height, forming towering walls of water. Upon reaching land, these waves unleash tremendous force, inundating coastlines and drastically altering the landscape. The aftermath can include widespread destruction, erosion, and long-term changes to the environment. Disasters such as earthquakes, hurricanes, and tsunamis do not happen by chance. Instead, they are the result of ongoing geological, atmospheric, and oceanic processes that shape our planet. These dynamic forces are constantly at work, driving the movement of tectonic plates, the circulation of air masses, and the shifting of ocean currents. Rather than being isolated events, disasters are part of Earth's continuous transformation. Understanding this interconnectedness helps us see that such events are natural outcomes of the planet's evolution, not random occurrences. This perspective highlights the importance of studying Earth's systems to better anticipate and respond to these powerful forces. According to the United States Geological Survey, megathrust fault zones are among the most powerful seismic features on Earth. These faults occur at subduction zones, where one tectonic plate is forced beneath another. Over time, immense amounts of energy accumulate as the plates grind against each other. When this energy is suddenly released, it can trigger earthquakes of extraordinary magnitude. Such events have the potential to cause widespread destruction, generate tsunamis, and even alter the rotation of the planet. The global consequences of megathrust earthquakes underscore the importance of ongoing research and monitoring in these regions. NOAA data reveals that supercell storms are among the most intense and complex weather systems on Earth. These storms are distinguished by their powerful rotating updrafts, known as mesocyclones, which set them apart from other types of thunderstorms. Within a supercell, wind speeds can sometimes exceed 300 miles per hour, making them capable of producing devastating tornadoes and large hail. The rotational structure of these storms not only fuels their longevity, but also contributes to their unpredictability and destructive potential. Supercells are relatively rare, yet they account for a disproportionate number of the most severe weather events. Their immense energy and organization make them some of the most powerful atmospheric phenomena ever recorded. The European Space Agency has conducted extensive research on volcanic eruptions that propel particles high into the atmosphere. Their findings reveal that these eruptions can inject ash and sulfur dioxide into the stratosphere, forming aerosols that reflect sunlight away from the Earth. This process can lead to temporary cooling of global temperatures and disrupt established climate patterns. The agency's satellite observations have helped track the spread and persistence of these particles, providing valuable data on their impact. Notably, large eruptions can influence weather systems for months or even years, underscoring the significant role volcanoes play in Earth's climate system. The World Meteorological Organization has documented that tsunami waves can travel at astonishing speeds, often exceeding 800 kilometers per hour. This remarkable velocity is comparable to that of a commercial jetliner, underscoring the immense energy carried by these waves. As a tsunami moves across the open ocean, its momentum is largely invisible, with waves sometimes only a few centimeters high. However, the sheer mass and speed of the water mean that, upon reaching shallow coastal areas, the wave's energy is compressed and unleashed with devastating force. This immense physical momentum enables tsunamis to travel vast distances with little loss of energy, making them particularly dangerous and unpredictable natural phenomena. Scientists have recently uncovered evidence of a largely invisible natural phenomenon that could act as an early warning sign for catastrophic events. This trigger, elusive and difficult to detect, appears to precede some of the most significant disasters in nature. Despite its potential importance, the pattern it follows remains only partially understood. Researchers are working diligently to unravel its mysteries, hoping that a deeper understanding could one day help predict and perhaps even prevent future calamities. For now, the scientific community continues to investigate, piecing together clues from scattered observations and emerging data. Natural disasters are often seen as unpredictable and destructive forces. However, they are also fundamental expressions of Earth's dynamic systems. Over time, energy builds and pressure shifts beneath the surface, setting the stage for dramatic events like earthquakes, volcanic eruptions, and storms. These occurrences are not random. They are the result of natural processes that shape and renew our planet. By understanding disasters as transformative releases within Earth's ongoing evolution, we gain a deeper appreciation for the powerful forces that continually reshape the world around us. Understanding the mechanics and warning signs of powerful natural forces is crucial for our safety and survival. These forces, often hidden beneath the surface, can reshape landscapes and alter lives in an instant. By studying their patterns and behaviors, we gain insight into the dynamic nature of our planet. Earth is far from static. It is a world in perpetual motion, where change can occur suddenly and dramatically. Recognizing early indicators allows us to prepare and respond more effectively. This awareness not only helps protect communities, but also deepens our appreciation for the extraordinary power and complexity of the world we inhabit.